Watch this. Watch this. So you got your paper in front of you. Let's do another example here. But I'm going to do an example with a map. What we're working on with the distance formula has to do with mapping. So when you have your smartphone in hand, you ever go to Google Maps? You ever do a GPS situation? It's using this, what we're learning right now, this formula, that's actually in the software, the triangulation. So let's go ahead and try something here. I want to give you this picture real quick here of a map here, down here. Where are you at? Where are you at, picture? There we go. It's a picture of a park. Check it out. Okay, it's a picture of a park. And what I'm going to do is I'm going to transpose it onto my board here. Okay, so you don't have to copy this on your notes because this is already, I'm recording this as we speak. Everything I teach I record and post it to the assignment. So on your notes, just go ahead and, what example are we on? We did 2 examples yesterday? What do we do? Does anybody have the notes from yesterday? How many examples did we do? Anybody, somebody? Help? Thanks guys, appreciate it. I'll say example 3. So go to put example 3 on your notes, because again, this is just a continuation of yesterday's notes. You do not have to copy this picture down because on example 3, go to put C video or pick. Okay? So if you're looking at your notes and you don't know where these points came from, just put C video for pick. For the picture, pick is for picture. And let's find the distance. Find the distance around the park. Around the park. That's it. That's all we're going to do. We're done with our notes. Let's find the distance around the park. Again, don't draw this, just put C video because the video will be available on C31. I'm recording right now and you can just forward it to the point where you see the picture. Okay. Rocking and rolling. So you got a park there, you got a little lake there where the duckies can swim. And what we're going to do is we're going to figure out the distance around the park. It's like a triangular shape, obviously. You can see that. Matter of fact, make it a little bigger so you guys can see here. Okay. All right. So notice what they did with this map. It's a map of the park. They transposed a coordinate grid above it. This is how mapping is done in real life. You want to know how many miles it is from here to downtown LA and you bust out your GPS to Google Maps? It's doing this. But it's all computerized with the computer code to do the calculation that we're about to do right now. So what you're learning is actually applicable real life stuff. Just the computer's doing it for you, but you got to know what the computer's doing, because that's like part of being like educated and stuff. So let's pretend Munguia is right here on the corner. Here's Mr. Munguia at point R, standing up. My cup of coffee. Okay. How far am I gonna have to walk if I walk around the whole park? How about this? From here to here, how far am I going to have to walk from here to get to point Q? Anybody?
80.
Close.
70.
Let's see. So we can see every tick mark of the graph paper is 10 yards, huh? So 1, 2, 3, 4, 5, 6, 70 yards. So I already know from here to here is 70 yards, huh? Again, you don't have to write this down because this is going to be on the video. So once I'm at point Q, how many more yards to point P?
40.
Thank you. 10, 20, 30, 40 more yards, yeah? Now from back to where I started, right? Back to where I started. Come on in. Now I'm going to walk with my cup of coffee from point P to point R, right where I started. So I have to walk 70 yards with my coffee, then 40 more yards with my coffee, and then back to point R with my coffee if I want to walk around the park with my coffee. Here we go. This is yesterday's learning, right? The distance formula. I'm going to write the distance formula off to the side right here. I'll write it in red. Here we go. The distance formula is x sub 2 minus x sub 1 squared plus y sub 2 minus y sub 1 squared. If you were absent yesterday, the video's already posted of me teaching this. So you'll have to go back later and like watch that and stuff and like study and stuff. Hernandez. Sorry. I thought you were like thinking deeply about the problem. So, point R, let me write the coordinates for point R right here, and then the coordinates for point P right here. That's both endpoints, right? Think about that. Okay, both endpoints. Let me get the phone real quick and pause this. All right, so let's figure out from P to R now, and we're down to the notes. Okay, so we have to figure out from P to R. We're done with our notes. Let's do this. Here we go. So the coordinates to R, the x and y coordinates for R. So where I'm standing with my cup of coffee, that's going to be 80 is the x coordinate, and then I'm going to go up 1 on the y, so that's 10 for the y coordinate. Notice that. So 80, 10 is where I'm standing with my cup of coffee. So far, so good. Point P, that's going to be, so to get to P, I got to go 10 on x, that's 10, and then I got to go up 50 on y, so 10, 50. Nice. So we're trying to figure out the distance between point P and point R. Okay? Point R. So remember yesterday, the very first step is assign your subscripts, your sub 2s and your sub 1s. Your sub 2s and your sub 1s. So I'm going to do that in red here. I'm going to make these my sub 2s, and I'm going to make these my sub 1s. Remember, I could have went vice versa. I could have made these my sub 2s, and I could have made these my sub 1s over here. Doesn't matter. As long as they agree for a given point, you're rocking and rolling, you're good to go. But let me just keep it the way I had it. Hate it when that happens. Okay, so let me keep it like this for now. All right, so let's rock and roll. X sub 2, here we go now, watch. X sub 2, the way I set it up is 80. So 80 minus x sub 1, the way I set it up is 10. Nice. Parentheses, square that puppy. plus, here we go, y sub 2, the way I set it up, is 10, minus y sub 1, the way I set up, is 50. Nice. Question so far? Again, this is just a review of yesterday, but we're just using our knowledge of yesterday to a real life situation. A real life mapping distance problem, right, Chavez? So I have the floor right now, so no phones on. I appreciate it, you're awesome. You get to look at that when I'm done. I'm almost done here. Here we go. Square root. Remember we did square root for warm up. So we have a calculator. You don't have to be scared of square roots. 80 minus 10, if my coffee is kicked in, it's 70 to the second power. Plus. Remember we did the Jamboard yesterday. 10 minus 50 is the same as, look at keep, change, change. So I'm adding the numbers with different signs, so that means I'm going to subtract, take the sign of the bigger number. In other words, 50 minus 10, I want to say is 40. But take the sign of the bigger number, so it's going to be a negative 40 to the second power. By the way, if you're still rusty with the negative and positives, just let the calculator do the work for you for now, okay? Look at my calculator. Watch. 10 minus 50. Negative 40. Okay, so let the calculator do the work for now if you're still rusty on negative and positives. Rocking and roll. 70 to the second power. I have no clue what that is, so I'm going to go to my calculator and hit 70 to the second power. Watch this. 70. Look, it even has the second power button automatically. That's kind of cool. 8 to the second power. Boom. 4,900. 4,900. Plus negative 40 squared. Let me go back over there, let the calculator do the work. Negative 40, square that puppy. It actually should be positive. The reason why it's negative is because it's interpreting it as negative 1 times 40. But this is going to be a positive 1,600 because negative times negative is positive. In other words, there. Now it's interpreted as negative 4 to the second power. So 1,600. So a little FYI. If you don't put the parentheses, it's interpreting it as negative 1 times 40 to the second power. So it does the 40 to the second power first and 10 times the negative 1. But if you put the parentheses around the negative, then it interprets it correctly. Just a little FYI there. 1,600. $49 plus 1,600. $6,500. Is that, yeah, 6,500. Nice. I have no clue what that is. I'm not going to do that in my head. I'm going to let the calculator do the work. The square root of 6,500. Square root 6,500 to the nearest tenth. Look at that. 80.6. 80.6 yards. Approximately 80.6 yards. So that's this last part right here. From point P to point Q, where I was standing with the coffee, is 80.6 yards. So if I wanted to walk around the park, it'd be 70 yards plus 40 yards plus 80.6 yards altogether. I'm not going to do that. You get what's going on there. Rocking and rolling. Beautiful. All right. So I was going to have you do a guided practice problem, but I wasn't anticipating the picture taking. So I'm gonna give you the rest of the time to work on the DMT for the day. When I say DMT, it's what I'm actually gonna grade now. The 4, 3, 2, or 1 for the day, it depends, is what you're gonna do now. In other words, go to Big Ideas through Clever. So hit that Clever button on your browser, the little C, scroll down to where you see Big Ideas, it looks like this. Looks right there, the big B, like an I inside of a B letter. You only have 2 problems to do and you can finish like in 5 minutes if you're quick, but you got the whole period. You got 20, 25 minutes left. Use the time wisely. If you're done early, work on anything else you owe me from yesterday. If you didn't finish yesterday's stuff, because those 4 problems due yesterday, get that in. So I'm giving you the rest of the period, free time, to get your stuff done. Be productive. Again, go to Clever, hit the Big Ideas, give that a shot. I'll be walking around to help, and I'll be sipping my really good coffee in the back next to my computer. Get big busy, go.